Hello guys, I'm Jatin Digra and I'm going to start my 92 video on SolidWorks. In this tutorial, I'm going to design the hexagonal nut. So this is the 2D drawing of this hexagonal nut. So by using this 2D drawing, I will make this part in 3D. So here I'm going to use the 4 basic features tool for making this part. So one basic features tool is the extrude pose. Second basic features tool is the whole extrude cut. Third basic features tool is the mirror, and the fourth basic features tool is the hole wizard. By using these 4 basic features tool, I will make this part in 3D. So just I'm going to sketch. So firstly, I will going to sketch this hexagonal. So just here I'm going to sketch command. So just take the top plane. So in the top plane I'm going to draw the hexagon by going to the polygon. The number of sides is the 6 mm, and the origin center of the circle it is at origin. Center of the polygon it is at origin. Just click over here. So just draw freely. As you see here, we know the dimension of this hexagon from this plane to this plane, or all the lines are equal size. So the across the plane it is about 12 mm. So just if we know the distance from this point to this point or this point to this point, so you can choose this one. Or if you know the distance from this line to this line or this line to this line, you can choose inscribed circle or circle. So I just choose this one, and the diameter of this circle it is about 12 mm, which is the distance from this line to this line. So just okay. Now I'm going to constrain it. So just under the constraint it is showing here, this is representing the equal sign constraint. Just I'm giving the dimension to this circle, it is at 12 mm. So now you can see here this circle is converted into black and this line is not black, so it means this circle is come into fully constrained, but this not. So I just taken this point and this point are at horizontal constraint, which is at, and now it's converted into fully black. So just go into the features tool, just into the extrude pose command. So here I am going to in the end condition I'm going to take the mid plane. So this sketch comes into a center of this. So and the extrude in both direction equally. So 6.5 is the end condition, which is showing here the dimension of this thickness. Just okay. So now as you see in the top view, here it is showing this circle, and if you see the front view, the outside from this circle it will be cut it down by 30-degree angle. So just firstly I'm going to draw the circle at this plane. So just going to the normal of this plane. So just okay, then I'm going to take the sketch and select the plane here, and here I'm going to draw the circle up to the tangent of this line, which is already shown here, this sign in a white box. So just okay, but it is not converted fully black, so it is not tangent. So just selecting both of them and constrain it by tangent. So now it's converted fully black. If you use now I'm going to the extrude cut. So here we have to cut the outside from this circle, that is in this portion. So you can choose this thickness features tool. So this 5 mm is represented that distance from this circle to this circle, this outer circle. So it doesn't matter because we have to cut on up to this point. The angle of 30 degree from this surface.
So the vertical angle it is about, if you go to the draft, we have to go to the draft and write it over here, 60 degrees from the launch. So you can see from this portion. So the other thing is okay. So I already cut it over here. So now we have to place this at this plane also. So we can place here by mirror. So you can just have as you see here, the mid plane is this. So you can mirror by this portion. So you can just go to mirror. The mirror face or mirror plane is about this, and the feature of mirror you can choose this one, and it will all. So now it is already plane mirror. So now I am going to the Hole Wizard features tool. So just as you see here in the arrow mark, if I just click over here, there are two options. First one is the Hole Wizard, second one is the threaded. So threaded represent that if we already drill over here, or if you already provide the hole over here, you just provide the thread on that hole. So you can choose this one, or if you have to drill or whether it's thread, so you can choose the first one. So here you can apply any type of. So here, as you see here is mentioned that these are the types of the holes. Like first one is a counter bore, second counter shunts, and third one is drill. Here, if we go here, so here we find that there is a type of this type of hole. The first one is a double hole. Double one is that hole which locate the two part in our assembly. So in that case, we have to use this double hole, which is generally used for just locating the position of the part. So, and the drill size, if you have to provide just drill over here, or you can choose this one, if you have to provide the screw clearance. Screw clearance is generally provided when we join the minimum 3 parts or more than 3 parts. So in the middle plate, in the intermediate plate, you have to just provide it the screw clearance. So in that case, you can choose this one. Or we have to provide over here is a threaded hole. It is a tapping hole which is showing over here. So as we know that if you are following the another standard, like we are following the DIN, which is the German standard, so you can choose on that. So just here you. And the types of the hole, the bottom, there are many other types, so you can just do one of that. So just I'm going. So we have to provide here, we have to drill over here, that is a M8, and the 6.8 is the drill size, which is, as you see over here, the meaning of this sign, it is represent that we have to drill firstly 6.8, then we have to tap M8. So just I'm choosing this one, going to like 12 over here. Like as you see here, that here it is already show M8, it doesn't, and here 0.25 is representing to the pitch of this thread. So if you choose this one, so the drill side it is about, if I am showing this, so drill side it is about 7.75 mm. So that is or if you go any one of that, if you go this one, so the drill size it is about 7 mm, or if you go this only M8, so the drill size it is about 6.8 mm. So as you see here, there is an option to which type of hole you can show. This represent only a drill hole, or this is representing the drill with tapping. This dotted line which is representing a tapping. So now I am going to place over here now 3D space. So just 3D on a 3D, taking the 3D sketch, just have to place over here. So yeah, just place over here, that is the 4. So now, as if you are going to the top view, so you can find over here that this is representing to a drill size, and this 3/4 circle, which is representing to a tapping. This is a design representation. This 3/4 circle in outward direction, so it is representing to the inside thread, or if it is a inside 3/4 circle, which is representing to the outside thread. So this is a common thing. So yes, this is the part which I have to design in this tutorial. Thank you. Have a nice day.